Hey guys, welcome to another tutorial video talking about how to solve the tasks in the Food Web Lab. So look at the previous tutorial video that is just above the link to this one on the assignment page. Go ahead and see how to do task 1. Today I'm going to be covering tasks 2 through 4. So let's go ahead and dive in. First thing you'll need is to go to your Food Web Lab Google Sheets, and then of course you'll want the Coral Reef 2 Biotic Factors Gizmo open as well on a different tab. So we are going to build an experiment off of the scientific question for task 2, which population is most important to the parrotfish's survival. Now let's figure out which populations are actually involved with the parrotfish. To do this, we need to find the parrotfish here in our coral reef gizmo to learn more about it. So I'm going to click on fish until I find the parrotfish. Aha! Here's the stoplight parrotfish. It says it's an important herbivore, that's an important word, it means that it eats plants, that feeds on algae, but may also damage corals, eaten by groupers, snappers, and other reef predators, current population 825. So what it tells me here is that it eats algae, so it is a primary consumer, and it is eaten by groupers, snappers, and other reef predators. So I'm immediately going to want to go ahead and I'm going to want to click stoplight parrotfish on my data, so I know that I'm going to be looking for that. And then it also says that it's eaten by groupers and snappers. So I'm going to find the Nassau grouper and the yellowtail snapper, and it said other predators, so I'm not exactly sure what those would be. I'm going to say maybe the lion, red lionfish as well. And then these right here, it says that it also may bother coral or damage corals, so I'm going to keep the corals on there. I don't really need the sponges, and I'm going to keep the algae because it's involved with the stoplight parrotfish. So basically what I've done is I've gone through and I've highlighted all of the different species that are related to the parrotfish using the simulation. Now with this information, I'm going to go ahead and try to come up with a guess as to which one is more important for the parrotfish's survival. Now I'm going to guess that the algae is more important for the parrotfish's survival because the parrotfish lives off the algae. But so let me show you something here really quick because I've seen this happen sometimes. So how I've seen some of you guys solve this is that you'll go ahead and you'll advance the year to see what happens, and then you'll go ahead and you'll try to remove the algae from the ecosystem by clicking this button. That doesn't actually remove the algae. It just hides the line for the algae. But if you go ahead and click it again, you'll see nothing changes except for the algae appears and then disappears. So doing this does not remove the algae from the population or change any of the other populations. It literally just hides that line. So we're not going to be able to actually use that to remove the algae. We're going to have to change conditions within the reef to affect the algae's population. And we're also going to have to change the conditions in such a way that it won't hurt the parrotfish too much. So I'm going to go into land use here really quick because I know that sewage affects algae, and you could do anything. You could change the temperature, you could change whatever, but I know that sewage affects algae, and so I'm going to go ahead and turn my sewage up here. I'm going to turn my sewage up to let's say 50%. Okay, I'm going to restart. I'm going to go ahead and run for 20 years. And I'm going to see what happens. Now, let's take a look at what's going on. Okay, we start off with all the species being at the normal population size. The sewage comes in and the algae population explodes. That's what I was kind of hoping would happen. And we see that the parrotfish immediately start exploding afterwards. So what's happening here probably is that the parrotfish are starting to eat the algae and they're starting to increase after the algae increases. And because we know that parrotfish damage coral, that makes sense because we start to see the coral populations go down. But here's what's really interesting. We get to this point with the parrotfish, and the parrotfish start to insanely decrease. Now, it might be because some of their predators, such as the Nassau grouper and the yellowtail snapper, start to go up, but those also start to go down in population as well over time. Okay, so we could even go a little bit longer than 20 years and see what happens here. Wow, they are all starting to really hit the dirt. So it looks like what happens here is that the algae makes the parrotfish spike a lot. So yes, the parrotfish are in fact very dependent upon the algae, but the groupers and the yellowtail snapper also seem to be pretty important. Okay, so I'm going to go ahead and take a picture of that graph because that's pretty useful. I'm going to right click or use 2 of your fingers on your touchpad to double click and say copy image. I'm going to go ahead and paste that in by task 2. So I'm going to kind of keep this around as a bit of information here. Okay, now before I go any further, I made the horrible mistake of not going through and doing my hypothesis and independent dependent variables before I collected data. It's always important to do this before collecting data, so I apologize for that. Let's do this now. So I said I thought that the algae was going to be the most important to the stoplight parrotfish fish's survival because the algae was going to be what they ate. So I'm going to go ahead and say that if the, I'm going to say I think that the algae is the most important to the parrotfish's survival, okay, because the parrotfish eats the algae. And if the algae, here's my real hypothesis part here, if the algae increases, the parrotfish will also increase. Okay, all right, over 20 years, let's say. Okay. Now I go down here to my independent variable. Now what am I changing? Well, what I'm changing is I'm going to increase sewage to 50% to increase the algae population. Okay, you can do whatever you want for your variable. My dependent variable is going to be looking at the parrotfish population survival. That's my big thing, survival. My control here is going to be everything at normal conditions, okay? So in other words, no sewage. Okay, my constants here are going to be everything I don't change, right? So everything but sewage. Okay, and my conclusion here. Now here's the thing though. I'm going to go ahead, I need a little method comparison because it says which population is most important for the parrotfish's survival. Now here, it seems to me that the algae is really important for the parrotfish's survival, but the grouper and the snapper also seem to be really important to the parrotfish's survival. So how do I go ahead and see whether or not they're not the most important ones to the parrotfish, okay? So actually, before I do anything, I'm going to need to add something to my hypothesis here. I think that the algae is going to be the most important. If the algae increases, the parrotfish will increase over 20 years, okay? And actually, I'm going to go ahead and say this, right? More than if the grouper or snapper let's go ahead and say increase. Okay, so I'm going to go ahead and say that and actually, hang on. I'm going to explain this in a second. So basically what I'm saying is I'm trying to do a method of comparison here. I'm trying to figure out which population is the most important for the parrotfish's survival. Here I've tested algae. I've seen algae is very important, but it looks like the groupers and the snappers are also important. So let me go ahead and see what happens if I remove them. Oh my goodness, I can't believe I just did that. Wow, I just got rid of my whole hypothesis and I can't get it back. Oh, that's so frustrating with sheets. Okay, so I'm going to do a simple version here, okay? I think that algae is more important than the groupers and snappers to the parrotfish's survival. And if the algae increases, it will allow for better parrotfish survival than if the groupers and snappers decrease. Now here's the thing, and so here I'm going to increase sewage to increase the algae population. I'm also going to increase fishing to decrease the grouper and snapper population. I'm going to show you that in a second. Well, basically what I'm saying is if I give the parrotfish more of its food source, it's going to grow more than if I took away its predators. So let's go ahead and take a look and see if that's true. So now I'm going to restart everything and put it all to the original settings. I'm going to go over to fishing, and I'm going to get rid of the grouper and the snapper, or at least severely damage their populations by saying I'm going to 100% fish out the grouper and the snapper. So let me go ahead and advance the year here. So we can see the grouper and the snapper are dead. They're died off. And the parrotfish, whoa, okay. All right, so the parrotfish were doing great without the grouper and the snapper. Actually, they did really, really well. And when the algae, actually here, if you look at it, the algae really was going down, and probably because there's a lot of parrotfish, but it really wasn't, affecting the parrotfish as much. The snapper, look at this snapper right here. The snapper was going down, but it started to come up. The grouper died out. The snapper really started to come up, and when the snapper came up, it must have been eating all the parrotfish because we can see the parrotfish start to plummet. So actually, I'm gonna go ahead and take a picture of this graph here and copy and paste it in. So actually, my conclusion here is going to be that when I actually look at this data, what I see here is I actually see that the snapper, the predator of the parrotfish, looks like it has a much larger impact on the parrotfish's survival in terms of how high its population can go than the algae does. Because when a ton of algae is abundant, the parrotfish only get to a certain point and they die off. But when there's the snapper around, when there's an abundance of the predator, or when the predator's gone, the parrotfish get really big. But when there's abundance of the predator, the parrotfish go down again. So I'm actually going to go ahead and come down here and say that my conclusion, the hypothesis was not supported because with an abundance of algae, the parrotfish still died off because of the predators like the snapper. And only when the snapper and grouper were gone did the parrotfish population really explode. And I could even say that when the snapper came back, that was the only time that the parrotfish really fell. Okay, so here's an example of how I went about solving it. Now, there are multiple different ways you could try to go about solving this and multiple different hypotheses that you can make and say whether or not they're supported. I'm not saying that yours is wrong. I'm not saying that anything else is true. This is just how I would go about solving it, one way of going about solving it. So task 3, it's asking which population is least important to the balance or survival of the ecosystem. Now, once again, we're faced with an interesting task. Okay, we're asked to go ahead and say which population out of all the populations, so I'm going to go ahead and check everyone. Which population out of all the populations is the most impactful or necessary for the survival of our reef ecosystem? Okay, so if I'm trying to figure this out, again, I'm going to have to start removing species to see what happens. Okay, and I'm going to have to decide which species I want to change to see how it affects the rest of the population. Okay, so if I'm looking at all my options in terms of the coral reefs, I'm actually going to go ahead and say that I think the boulder star coral is going to be the most important species in this coral reef. Okay, now why I'm saying that is the coral reef is built off of coral, right? Okay, and so I'm imagining that the coral is going to be important. I could have chosen the staghorn. I'm going with the boulder star coral. No real reason why. It's just, I'm just going to go ahead and make my hypothesis. So for my hypothesis, remember your hypothesis doesn't have to be right. It's just an educated guess. So I'm just going to go, well, really it's an argument, not just an educated guess. But I'm going to go ahead and say that if the boulder star coral decreases, it will have more of an impact on the coral reef population than if and now I have to choose a different species that I want to remove, and I'll go ahead and say, what else can I remove here? I'll say the sea urchins. I can remove the sea urchins. So I'm going to say then the sea urchin population. Okay, I don't really know what the effect of the sea urchin population is, but I'm going to see what happens when I remove it. My independent variable. Okay, so how am I actually going to remove the boulder star coral? Well, when I go over here to the disease, after playing around with the variables, I've actually noticed that if I remove the, or rather if I turn up the black band infection rate all the way to 100%, my boulder star coral goes way down. So that's how I'm going to go ahead and remove it from the environment. So I'm going to go ahead and say, for my independent variable, I'm going to say my black band infection rate at 100% to get rid of boulder star coral. And to get rid of the sea urchins, I can easily do that using the sea urchin infection rate and 100% sea urchin infection rate to get rid of sea urchins. Those poor little urchins. My dependent variable, what am I going to be looking for? I'm going to be looking for changes in the populations of the coral reef, right? Because that is what I'm going to be looking at to see, because I'm asking which population has the biggest impact on the balance and survival of the ecosystem of the coral reef. So I'm going to be looking at the changes in populations based off of these changes to see what happens. My control is going to be everything at normal settings. So in other words, it's going to be these two at 0%. Constants is going to be everything but black band infection rate, and I'm going to say everything normal settings, but black band infection rate and sea urchin infection rate. Okay, and I'm going to go ahead and try it out. So the first thing I'm going to do is remove the Boulder Star Coral with the black band infection rate. So I'm going to go ahead and advance my years to 20 years. Basically got rid of the Boulder Star Coral, and wow, it really did not do much at all. Most of the population stayed pretty much the same, except for the Staghorn Coral, which seemed to do really well, probably because it's a competitor with the Boulder Star Coral. So I'm going to take a picture. I'm going to go ahead and copy that and save it over here into my handy dandy sheets. All right, and then I'm going to go ahead and remove my sea urchins. So I'm going to go back here, return to original settings, restart, sea urchin at 100%. And wow, oh my god. So I got rid of the sea urchins pretty quick, and everything lost their minds. The algae and the parrotfish and the groupers and the snappers all went up, and then we saw an incredible decline. Everything starts going down. So we see our, wow, we see so much. Okay, so our coral basically tanks. Our staghorn coral, our Boulder Star Coral is heading there. Our parrotfish are probably tanking because the groupers look like they're taking over, right? The snappers are going down because they're probably being outcompeted by the groupers for the parrotfish. And the algae is the only guy that seems to be doing okay. But in terms of impact, wow, the urchin had a lot bigger impact on this than the Boulder Star Coral. So once again, as I'm looking at these guys and comparing these graphs, I am going to say, for my conclusion, the hypothesis was not supported because when the Boulder Star Coral was removed, most populations remained the same, except for the Staghorn Coral, which actually did better. And when the urchins were removed, populations, we'll go ahead and say most populations rose rapidly, but then most crashed immediately after. Okay, so that is going to suggest to me that the urchin has a lot more impact than the Boulder Star Coral did. Now we get to task 4. Task 4, we want to create a line graph using the data set on the right. Okay, so we should have created a line graph for our pond ecosystem lab. But let me show you again how to go ahead and do that. So to create a line graph, or any kind of graph, in Sheets, you want to go ahead and highlight your data. You want to make sure that all the data is highlighted, including these titles. And it should be all in blue. So how you do that is you hover your mouse over the upper left-hand corner where it says time, you click and you hold, and you drag all the way down to the bottom right where the last data point is for grouper, you let go, and now the whole thing is highlighted in blue. We now want to go up to the insert button underneath the name of the assignment, which is Food Web Lab. Press insert, and we go down to where it says chart in the drop-down menu. We're going to click on chart, and that should automatically generate a line chart. Now, if it does not automatically generate a line chart, and it generates something crazy looking, go over here to where it says line chart or whatever you have, and you're going to go in here and you click on line chart. Okay, so that should give you a line chart, and it should automatically generate with everything that you need to know. You can go ahead and put it over your data, it's fine. The graph basically is your data. Okay, so then you're going to answer some questions. Question 1, which population is the first to crash? So to answer that, you're going to look for which line hits the bottom first. Okay, it seems to be this red line. You can read what that is. Okay, why did it crash? In other words, what populations did it depend upon that weren't strong enough to support it? I think you should be able to figure this out based on what we've already talked about. Why would the parrotfish crash? What food source does it rely on? And what was happening with that food source just before the parrotfish crashed? What other populations crashed and why did they crash? Okay, so we can see that in addition to after the parrotfish crashes, we see the grouper crash. That's probably a pretty easy thing to figure out. And then the starfish is crashing as well. We could go back into the coral reefs and we could figure out what exactly is going on here with the starfish. I'm going to restart and get everything to original settings and see if I can find the starfish, sponges, staghorn coral, long spine sea urchin. Wait, are there any starfish? Oh, crown of I have to put it in there. I see. Sorry, it's a condition, so let me put the starfish in there. Alright, now let me see if I can find the starfish. Wow. Geez, you know, you really think they were going to put them in here, and I just don't see them. Okay, so we can go ahead and see what do starfish eat. Pretty sure it's fish. They are carnivores. They feed on coral, sponges, clams, oysters, sand dollars, and mussels because these animals attach themselves to rocks and move slowly. Interesting. So if we go back to our graph, we can see that our algae is going down at first. We really don't have anything for the coral, so maybe we can guess for the starfish population that the coral is also dropping, and that's why they drop. But we can't really tell from this graph. I apologize for that. I thought that that data would be sufficient for that, but you can comment on the grouper pretty easily because it's obviously crashing because the parrotfish crashed. Now, how many months does it take for the algae birth rate to rise higher than the death rate? Well, let's take a look at the algae graph. The birth rate and death rate refers to how fast or slow the population is growing or shrinking. If a population is growing, in other words, the line is going up, the birth rate is higher than the death rate. If the line is going down, the death rate is higher than the birth rate. In other words, more people are dying out of the population than are being born into it. So at what point do you see the algae line, which is this blue one here, actually start to go up? That is where the birth rate is higher than the death rate. That's how you can tell. What would an ecologist do to save or balance the ecosystem? Now, I'm not going to give you the answer here, but I want you to take a look at this. Which population seems to be the one that is most important? Which one went down and brought all the others with it, and what can an ecologist do with that population to go ahead and make sure that that would not happen? So how could an ecologist add back one of these species? Which one should it add back in order to bring balance back into the community so that stuff doesn't crash again? I'll go ahead and let you ponder that, but that is how you do task 2 through 4 in the Coral Reef Lab. I know this lab was very difficult. I know I didn't give a lot of guidance beforehand. Thank you for your patience in this lab. It is a new one for me, so I'm still kind of learning how to teach it, but hopefully this will help you guys out in doing the lab in your corrections. Remember, you may do as many corrections as possible, and there are no late penalties for turning in your work, so long as you get it to me within the end of the marking period. Thanks, guys, and have an awesome day.